Okay, so in this video, we are going to take a deeper look into explicit functions. So our objective is still the same as before. Students will be able to write an explicit function for an arithmetic sequence. Given a sequence, students will be able to write an explicit function from the first term of an arithmetic sequence. And actually, in this one, it's going to be from any term in our sequence. So let's start off here finding the missing terms of each arithmetic sequence and then stating the common difference. So like we've said before, an arithmetic sequence is a sequence that adds the same amount. So if you're not adding the same amount, then it's not arithmetic. So even though we don't have these two terms in the middle, we do have two terms in a row. And we can see that to get from 5 to 11, we would add 6. So, and from 23 to 29, we add 6. So since it's arithmetic and they told us that, then we know that 11 plus 6 would give us the 17, and 29 plus 6 would give us the 35. That is the missing terms because our D is equal to 6. So looking at number 2, you can apply the same concept. To get from 7 to 3, I minus 4. To get from 3 to negative 1, I also minus 4. So I'm going to continue to do that. So negative 1 minus 4 is negative 5. Negative 5 minus 4 is negative 9. And then negative 9 minus 4 is negative 13. So I know that we've done it correctly. You do number 8. You would have seen that to get from 47 to 60, you add 13, giving you a D value or a common difference of 13. So then you would do 8 plus 13 to get to 21, and 21 plus 13 to get to 34, and then 34 plus 13 gets you to 47. So that's how you could double check to make sure it works. Jumping on down to this section. In this section, we're just going to compare recursive and explicit functions. So we've been talking about these two pieces for the last couple of days. So I'm actually going to come over to the side and we're going to write just a general form. So for an arithmetic, our recursive function will always be f of n is equal to f of n minus 1 plus our common difference, and we'll always give a starting term. From here, we've usually given the first term, but you can give any term, and we're going to talk about that in just a second. In the explicit function we saw yesterday, we had f of n was equal to f of 1 plus d times n minus 1. And we talked about the fact that these two numbers needed to be the same. So you can actually take that number out and just leave kind of a blank there. These two numbers, whatever they are, just need to be the same. So what ends up happening is your D value comes down over here. This value goes right here, and this value goes right here. So let's look at this example. This recursive says that I have the next term is the previous term plus 3. And then this here says my second term is 8. So I've not given the first term, I've given the second term. If I then want to write that into explicit form, we can kind of go off and make a table like we did yesterday. So our n value, we're starting with 2. So n is 2, and we have 8. So then I'm going to use my common difference to get my third term, which is 11. And then get my fourth term by adding another 3 to get 14. So yesterday we expanded things out. So this was 8. So then this is going to be 8 plus 3. And this one's going to be 8 plus 3 plus 3. My fifth term would be 17, which would be 8 plus 3 plus 3 plus 3. And then my next term, my sixth term, would be 20. which would be 8 plus 3 plus 3 plus 3 plus 3. So if you notice, it's the same as yesterday, adding 3's, but now instead of being 1 less than my term number, like they were all yesterday, now I have 2 less than my term number. So this is term number 3, because remember n is my term number. I have 1 3. At term number 4, I have 2 3's. Term number 5, I have 3 3's. Term number 6, I have 4 3's. So to write the nth term, it would be 8 plus 3 times n minus 2, which was the term number I had. So you see that connection of 8 is the term that I'm starting with, and it's the second term. So when I want to write my explicit, I'm going to write my first term that I have. Well, actually, start at f of n, write the term that we have, say what we're doing, we're adding 3, and then we're going to do it n minus 2 times because we're starting at the second term. So that was just like a little side cap to then help you see how to determine these. So on the worksheet, we want to determine if it's an explicit or recursive function. Then state the common difference, the term and term number given. So when I look at number 7, I have that f of n is equal to 4 plus 5 times n minus 3. I have a bunch of numbers in that, so that will help me know that it's an explicit. I can plug straight into here my term number and get out the term that I have. I can see that I'm adding 5 here, so that's my d value. The 3 in the parentheses tells me that's the term number, and 4 is the term. So my third term is 4 with a common difference of 5. When I look at number 8, I have f of n equals f of n minus 1 minus 3. F of 1 equals 9. I don't have an equation I can just plug into, so that makes it recursive. Also, they're telling me a starting term and exactly what to do. So my d value is negative 3 because I'm going to minus 3 every time. My term number is 1 because that's what's in the parentheses, and 9 is the first term. You try and do number 9 on your own. You should have seen that since you cannot plug into this equation, and they give you a starting term, that you have a recursive function. Since they're telling you to add 15, that is your d value. 5 being in the parentheses tells you that the fifth term is negative 8. Jumping on down to the bottom part, this is the last piece that we'll talk about, and then we'll finish this up in class. Sometimes we don't always have the first term of a sequence. We can still write the recursive and explicit function from the given terms. We just need to adjust our term numbers. So for each of the given pair of terms, write the recursive and explicit function. So if f of 3 equals 5 and f of 4 is 8, so those are 2 terms right there in a row. So I can see that to get from 5 to 8, I need to add 3. So I know that my common difference is 3. That helps me get my fifth and sixth terms, which would then be 11 and 14. Now, if I can write my recursive function pretty easily, just using my third term. So f of n is equal to f of n minus 1 plus 3 with a third term of 5. The explicit is the more challenging piece. So to do that, I'm going to come over here and I'm going to make a table of values. So I have that my third term is 5, my fourth term is 8, I found my fifth term to be 11, and my sixth term to be 14. I'm going to write these recursively now. So the 5, I didn't add anything to get there. The 8, I added 3 to 5. So at 11, I added 3 to 8, which was 5 plus 3. And then to get to 14, I added the 3 to the 11, which was 5 plus 3 plus 3. So add another 3. Now I can write this into simplified form. So I like to start from the bottom. So I rewrite this as 5 plus 3 times 3. The one before that would be 5 plus 3 times 2. 5 plus 3 times 1, and just 5. Now I want to compare these numbers here, because those are the only pieces that are differing, to my n values. Really, I can write this plus 3 times 0. So I can see that to get from 3 to 0, I need to minus 3. And 4 minus 3 is 1, 5 minus 3 is 2, and 6 minus 3 is 3. So it's very similar. It's just that instead of starting with the first term, I've started with the third term, which means that I didn't need to add the other terms in first. So my n value would be 5 plus 3, and I get to n by doing n minus 3. So my explicit function will be f of n is equal to 5 plus 3 times n minus 3. And we see again that that third term is 5. In class tomorrow, we will work the rest of the examples on this page, and I will answer any questions that you may have. I'll see you then.